On the 19th of February 2008, a short internal report from a Sukhoi test center stated a single sentence that would later become symbolic for an entire generation of Russian aviation. The platform demonstrates potential beyond expectations. The aircraft mentioned in that document was the Su-35, a machine that would soon redefine what a modern air superiority fighter could be. Its road to becoming a dominant presence in the skies began long before this report, formed from structural failures, political pressure, and breakthroughs that forced engineers to reinvent the foundation of the flanker family. The concept of the Su-35 emerged in the late Soviet era, when the need for a long-range, highly maneuverable fighter capable of outperforming Western rivals became strategic priority. The original Su-27 was powerful, but the rapid evolution of radar systems and missile technologies showed that the next-generation battlefield demanded something far more advanced. Early prototypes, known as Su-27M, appeared with experimental avionics, large canards, and new control systems. These aircraft were promising, but too complex for mass production in an unstable political period. As the Soviet Union collapsed, the project was shelved, leaving behind only lessons that would later be resurrected. By the early 2000s, the modernization of Russia's aerial forces became essential. Sukhoi engineers studied archives of the abandoned Su-27M program, extracting both successful solutions and critical mistakes. They realized that the new fighter must preserve the aerodynamic advantages of the flanker, but incorporate a next-generation digital core, new engines, new radar, and a drastically strengthened airframe. Unlike previous attempts, the Su-35 had to be both powerful and reliable, capable of long patrols, quick interception, and instant transition to high-G maneuvers without structural fatigue. The transformation began with the airframe. Engineers removed the canards of earlier prototypes and redesigned the internal skeleton using lighter but stronger materials. Load distribution was recalculated from scratch. The Su-35 received enlarged control surfaces and a new tail design, giving it agility despite its size. The aircraft maintained the signature flanker silhouette, but every line was optimized for minimal drag and maximum stability during extreme movements. The engines became a decisive element. The AL-4-1F-1S power plants introduced thrust vectoring nozzles capable of redirecting exhaust streams in multiple directions. This gave the Su-35 a level of maneuverability unmatched by most fighters of its class. It could tilt, rotate, and reorient its nose toward an enemy aircraft, even when traditional aerodynamics offered no support. Test pilots described these capabilities as controlled impossibility, since the aircraft could maintain stability in flight regimes previously considered unattainable. The avionics suite transformed the aircraft from a maneuvering platform into a multi-layered combat system. The Urbis-E radar provided detection ranges exceeding several hundred kilometers, with tracking capabilities for multiple targets at once. The aircraft's onboard computer was fully digital, integrating electronic warfare modules, target recognition, and long-range missile guidance. Engineers designed the interface to reduce pilot overload and shorten reaction times. Instead of fighting the aircraft, the pilot could now focus entirely on the mission. Weapon integration completed the shift. The Su-35 could carry a wide range of air-to-air missiles, precision strike munitions, and anti-ship weapons. This made it capable of switching roles mid-flight, from interception to deep strike penetration. It became a multi-purpose heavyweight, maintaining dominance even in contested environments filled with electronic interference and decoys. Its first demonstration flights stunned observers. The aircraft performed maneuvers that appeared to defy physics, transitioning from vertical climbs to flat spins and back into controlled flight with minimal altitude loss. These displays were not theatrics. They reflected practical capabilities that allowed the Su-35 to evade enemy missiles, outmaneuver opponents, and engage targets at angles previously impossible for heavy fighters. Export interest soon grew. Foreign delegations noted not only the fighter's maneuverability, but also its structural endurance, electronic warfare systems, and long-range detection. Countries seeking an advanced air superiority fighter capable of independent operation over large territories viewed the Su-35 as a powerful alternative to Western platforms. With each successful delivery, the aircraft's reputation expanded. Engineers continued refining the design. Surface panels were reworked to improve stealth characteristics. New software packages increased processing speed and electronic countermeasure efficiency. While not a stealth aircraft, the Su-35 integrated enough low observable features to complicate detection during long-range patrols. Combined with its radar power and missile load, this made it a formidable opponent even for more modern stealth fighters relying heavily on first-look advantage. Operational deployments demonstrated the aircraft's resilience. In harsh climates, long flights, and complex mission profiles, the Su-35 maintained high readiness levels. Its engines tolerated extreme temperature variations, and its avionics network remained stable despite heavy workloads. Maintenance teams reported that the refined internal layout simplified inspections and repairs, reducing turnaround times between sorties. Through years of development, testing, and modernization, the Su-35 evolved from a theoretical successor of the Su-27 into a machine built for absolute air control. It was not created by accident or as a single breakthrough. It was the product of accumulated experience. Lessons learned from abandoned prototypes, re-engineered structural concepts, and technologies that matured precisely when they were needed. The aircraft became a synthesis of brute force and digital precision, able to maneuver aggressively while managing complex electronic environments. The Su-35 became a monster not because of one feature, but because of the combination of power, endurance, sensors, weapons, and adaptability. It represented decades of design, evolution, and the strategic need to create a fighter capable of meeting modern threats head-on. Its story reflects the transformation of aviation engineering from mechanical control to fully integrated electronic dominance. In the crowded sky of modern warfare, the Su-35 remains one of the most capable and feared aircraft of its generation. Its presence continues to influence strategic planning, test rival technologies, and define what a high-end fighter must be to stay relevant in the rapidly changing world of aerial combat.